Okay, let's start with our next slot. Are we all here? Evo ima ovdje još tri slobodna mjesta. There are still free places here. Okay, let's start. Our next presenter, Aleksander Radovan, will tell us about immutable collections in Java 9 and do we need them. Aleksander, please.
Thank you so much. We have few free seats here in front, so please join us. You'll have a nice view of the presentation. So thank you for introduction. So my name is Aleksander Radovan and I work for King ICT as a Java team lead, and I like to talk about some, let's say, interesting things related with the newest versions of Java. For example, one of the new features that were introduced with the newest release of Java 9 was related with the new factory and utility method for creating immutable collections in general. So, do you use immutable collections at all during your office hours? Yes. Do you like them? Yes. Why? They have restrictions. You cannot change them after you actually create an immutable list. What's good about them? Are they better? Do they work better? Let's try to give the answers on those questions. So I have some candies here, so if you give me some right answers, you can get a candy. Catch, please. Serian. Oh, sorry. Okay. One down, let's go. So, firstly, what is better, to use a mutable or immutable collection? First, it's something that you cannot change after you create the immutable collection. But sometimes you need to change, you need to sort, you need to delete, remove items from the list, from the set, from the map. So, it's not a good thing if you get always the exception that tells you that you cannot change something. For example, what is the most famous class in Java that is immutable? String. Oh, more candies. Who said string? No one. Catch. Okay, so string, of course. Why? Because if you change something, strings creates a new instance immediately. And is that a good for your memory? Well, maybe, maybe not. And of course, if you want to make your string mutable, you need to use what? String buffer or string joiner. Did you know about this class, string joiner? Did you try to use it? I need to remove this thing a little bit. No? If you like lambdas, you like string joiner also. So you can do, well, you can do various things with a string joiner. It is better for me to be here or there. What is better for you? Because of those things, yeah. Okay, so now in Java, you get something unusual, maybe unexpected after you actually try to do something with your list. For example, you want to delete something from the list, or you need to sort the list. Unsupported operation is thrown. This means you cannot do this particular thing. And no null element is allowed for your list. That it's not necessarily bad, because null pointer is one of the most often exception in Java. So that's why you can avoid those things. You can use optional, of course, but to cut the problems in the roots, it's also a nice way to avoid them. And there is no special interface for mutable methods. Well, if you don't implement something that explicitly, so to say, present your solution as a mutable or immutable collection, well, you cannot be sure that you are not allowed to call mutable methods for an immutable collection. But is there a solution for that? What do you think? Do you know Google Guava library? Did you try to use it before? No? Google Guava library is something that makes your code, so to say, better, and it contains so many utility methods so you can use it. Also, to have the opportunity to implement immutable set, immutable map, and immutable list classes. That means that you just add the behavior and the inheritance of those nice features to your classes. Okay, so let's go through the kind of history of immutable connections. Everything started very early, so prior to Java 8, before Java 8, we needed to use something like that. Do you recognize those characters here? Yeah, but are those characters related with some very popular, excuse me? No, close. Game of Thrones, candies, more candies. Who said Game of Thrones? Who said Game of Thrones? One more, yes, okay. So, firstly, yeah, this is an example how to create array list that is immutable. This means you need to call this utility method that actually adds this immutable behavior to your list. Can this part be shorter? What do you think? Can we cut some unnecessary lines here? Let's see. In Java 8, one-liner, of course, the most popular methodology in software development. Let's do everything in one line. But do you know those characters here? Come on. This is easier. Excellent. Now I don't need to throw candies away. So please, you have to take at least one because lunch is close. Okay, so we use this reference to a method unmodifiable list, and you use those things that actually create with the collect method, create the list, export the list, and there you are. You have the list that is immutable. So, can this be better, shorter, faster, stronger? Let's see. Java 9 has something like that. List of, set of, map of. But the main question, who are those person strings here? Do you recognize those? Come on. Something related with Turkey, soaps. No, it's running on our Croatian television, like something like Istanbul Bride or something. No, you're not? Okay, so. But the main thing here is it's shorter. You just list all the strings within the list of method, and there you are. You get the list that can be modified and is immutable. Okay, so first we need to check the performance of those lists. Why should we use immutable list at all? Firstly, it would be nice to check the speed, the performance, the timings that are actually there when the most common operations are performed with the list. So I've discovered that Java 9 also introduced a Java 9 microbenchmarking feature. Did you try to use it? Something like, let's measure how many operations per second are executed within the Java virtual machine and to compare those results. Let's see. Okay. This means, firstly, it is implemented by the real authors of JVM. And of course, it includes phases like warm-up, code optimization paths, and of course, the benchmarking should be very, very simple to implement. Prior to this version 9 of Java, you had to do many unnecessary things. But now you have so many useful things that, and of course, annotations that can be added to your class and methods to get the benchmarking up and running in a minute. Okay, so Java benchmark harness means, well, a toolkit that helps you to implement Java micro benchmarks correctly. So within few, let's say, minutes, you can get the first results. That's the main point, that's the main message here. Okay, and it's developed by the same people who implement the Java virtual machine. Well, impressive. And you just add the benchmark annotation to your class. Okay, is that the only annotation? Of course not. Let's see how many different types of benchmarks do we have at all. So, throughput. Throughput reminds you of number of operations per second. This means how many really physical operations you need to execute to get a result, to get the outcome measured in time. Okay, average time, the most popular, since you have to check if your application works, for example, in many different situations, and you just take the average time to see, well, if this behaves like you expected. Okay, sample time is also a type of the benchmark mode, which means how long it takes for the benchmark to execute, like one single, let's say, transaction, and of course, single shot time, how long a single benchmark method execution takes to run. Okay, these are the options. Now, it should be nice to have those options as input parameters to have the way to have a nice possibility to configure your benchmark test. Okay, and if you need everything, well, you just say everything, I need everything. So this is an example of a very, very like hello world benchmark test in Java. Firstly, you need to have this void main method, and you need to call this openjdk jmh main, and you just forward the arguments. And now, first annotation is benchmark. This means, does this remind you of something familiar, something related with testing? JUnit testing, for example? Yes, you just put a test or before, after, tear down, and everything else, okay? So fork means how many times do you want to perform this test, and how many warm-up cycles do you want to actually perform and execute. And you are able to choose this benchmark mode. And of course, here is the example, like a short example on which the perform is executed. And be prepared for that. If you want to try to, well, test this, you have to start thinking about the time that the test needs to finish. For example, something like that needs like 2 or 3 minutes to finish. So it takes time. So it does the warm-ups and, of course, tries to execute the number of tests to get the result. So that's why it seems like, well, I need only a few milliseconds. No, you need more time for that. Okay, so after that, we have another class that needs to be added to your micro benchmark, and it's called a state class. State class is something like, let's say, a configuration for your benchmark test, and of course, it starts with a global class level annotation that contains this scope benchmark configuration parameter, which actually defines what do you want to do with your test. After that, you just create this method, initialization method, which actually also defines a level of invocation that this test is applied to. And of course, we have like, let's say, we try to test our lists with strings and integer numbers, and we try to put 10 million values to the list, and we try to get the lists, get the integer values from the list, just to be sure that we have enough values to check the performance of our immutable test. So, to ask you right now, what do you expect? Is a mutable version of this code faster than the immutable code? What do you think? Which one is better? Which one is faster? Since the immutable class throws exceptions, is that slowing the code down or not? What do you think? No? Whoa, let's see. We have a last slide with results, so maybe you can be surprised maybe. Okay, so this is our code, which actually adds random numbers to our list. And of course, this is a shorter way how to create an array, populate an array, and add an array to this list. You don't need to, so to say, list all the possible values, especially if you have 10 million values. It would not make sense to create something like that. You just add an array, convert this array to a list, and you have an immutable list. Okay. There are also state scopes that you can choose from. For example, the first one is a thread scope. Thread scope means each thread running the benchmark will create its own instance of the state object. Of course, logically. Group, maybe you have a group of threads and you have to use them all to measure their performance. And of course, the last one is the benchmark. All threads running the benchmark share the same state object, since maybe it's like an initial state for all your tests. Like in JUnit world, so to say, you have this setup method that is called before every single test method in the class, so you can get the same behavior. Okay, setup levels are also like something that makes a configuration of your micro benchmark test. You can use a trial as a method is called once for each time for full run of benchmark iterations, and of course the method is called once for each iteration, and of course invocation that we used, the method is called once for each call of the benchmark method. Since we had two methods, one that actually tests the integer values, getting 10 million integer values from the list, and of course the other one was with strings. So let's see the results. First, after you finish your benchmark, you'll get something like that. Run complete, total time. Well, this is something very short. Sometimes the test can take like hours if you have something very complex to measure, to check. And of course, benchmark, count, score, errors, units, and of course, you have the numbers here. So this means how many seconds do you need for a operation, micro operation on your microprocessor? What do you think? But if you multiply this with 10 millions, you will get a bigger number. So that means the operations are very fast, but you need to perform many operations. Okay, so the results. Who will win? What do you think? The first, we started with 10 million values and we measured average time. The first one, fetching integer values from the list. 10 million integer values. Who will win the race? What do you think? Immutable lists or mutable? There are candies here, guys. I know you are hungry. We are waiting for the lunch. Why? Okay, it's faster. Really? You'll get a lot of candies. Why? Because the answer is correct. 15.8% faster. Okay. Yes? Because, firstly, you don't need to implement all those methods. They are actually implementing the mutable version of the list. Firstly, you just lock down some things that are not needed. And that's why for a bigger amount of operations and for this warm-up phase, you get a better results. So that's why it's not only, usually we have a list with most like 10, 20, 30 objects. But if you test the implementation with 10 million objects now, some things are, so to say, obvious. What about the string values? who will win the race in this case? What do you think? Or is the error the same? The same? Did you heard of this optimization of strings that came with Java 9? Yeah, we are not using all unnecessary space to, well, to save all the characters. We are saving space, so that's why you don't need everything that were used in Java 7 or 8. Okay, so the results are immutable collections are 4.7% faster. I generated like 10 million string values, random strings, like I didn't put like only few possible versions. No, I just generated like 20 characters string length strings with the 20 characters, so you got this result. So I repeated every measurement like 10 times, at least 10 times, to minimize the error. And also, it's very important not to do anything else with your computer during the microbenchmarking, because everything else can affect the results greatly. So that's why leave your computer to the night and you just analyze the results. Okay? So, conclusions are immutable collections good or bad? What do you think? Should you start using it, or you just continue like you did before? Because now it's much shorter to get a mutable list. List of something, something, and there you go. Okay, so if you need a list that needs to be populated only once, do you need such a list? Only once, without adding things or removing things or changing or sorting is also something that is forbidden in that case. Immutable list can be a good choice. For example, if you have those very often in the real world, so to say, code books, like list of cities in Croatia. Do you change those lists? Do you change those values? Not really. But if you use it very often, you can use this approach. So, faster than mutable lists. So, in those two situations in which I started the micro-benchmark measurement, I got those results. Maybe with Java 10 and with new garbage collection, maybe we'll have different results. Let's see. We have to wait for 6 months to get Java 10 and new garbage collector to see the results. Okay, and the immutable collections are easy to use with Java 9, of course, because you have this one utility method, list of, and there you go. And the last question, do you need them? Do you need immutable lists after you saw the results presented here? It's up to you. Maybe you can still stick to your usual way of programming or give the opportunity for immutable list. Yeah? Uh-huh. Okay. Okay. Mm-hmm. 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 Of course. For example, yeah, I agree with you. Mm-hmm. For example, Java has this vector implementation. Vector is a trace-safe type of a list. So, who uses vector collection in 2018? Jay Hipster, great answer. So that's why you also have like some older legacy types of collections that actually bring those trace-safe functionalities with them. Of course, I completely agree with you. But in this case, I was just focusing on a single, let's say, scenario in which is very often present in the everyday's work of a programmer. So that's why lists, sets, maps are the most popular collections nowadays. So that's why, yeah, you shouldn't ignore that. But you if you want to get a better results, and of course, if you need to check what is better to use, if you have the choice. Maybe I don't need to change the list after I initially created it, and of course, if you need to change it, the mutable are not the option, because you will get an exception that breaks your code. So, do you like immutable collections, or this is something for, let's say, adventurer programmers like me to test their performance? Thank you so much. Here are the candies if you're hungry. If you have any questions, I understand there's lunch, so see you in a few minutes.